Hey everyone, welcome to our second class of the year. Today we're going to talk about the domain of a function, which we mentioned in the first lesson. Okay, your aim for today is how do we find the domain of a function and express it in set builder and interval notation. So set builder and interval notation is hopefully something you remember from Algebra 2. It's just a way to express a set of numbers on the number line, right? We'll go over it in class, okay? Your homework for today is actually going to involve the textbook. So I will post this on Google Classroom, but it's going to be the OpenStax textbook, which is open source. So we're free to use it. So this will be a different textbook than the one we normally use in our pre-calculus class, because that one is not open source. So I cannot unfortunately share it online. But anyhow, it's page 35, numbers 9, 13, 23 to 26, and page 37, number 61. For this question, number 61, I want you to ignore where it says range for part C, so I just want you to calculate domain, okay? But yeah, I'll post this assignment on Google Classroom, so we have that for reference. All right, from here, I'm gonna jump to the do now slide. So if you wanna copy this aim or the homework right now, you can pause the video here. Otherwise, I will move on to the do now slide. Okay. Zoom out for a bit. Okay. So here's the do now for today. What is the domain of the following function? The function here is f of x equals 1 over x squared minus 4. And just a reminder for you, the domain of a function is a set of all allowable values of x. Same homework assignment. Okay. So I want you to pause the video here and try it on your own. And then after that, I'll review. Okay. So here, if you remember from last year, you'll remember that a fraction cannot have 0 in the denominator, otherwise it's undefined, right? So that would be room for where we can find, right, where the function is restricted, right? So like which values of x are not okay. Another way to say that is which values of x will make the function undefined. Okay, I'll say that again. So which values of x will make the function undefined. If we exclude those values, right, we will get the domain. Okay. All right. So in other words, we can set the denominator not equal to 0. Right. We can't have that be 0, otherwise it will be undefined, right? So from here you can factor to x minus 2 times x plus 2. So this can't be 0. So in other words, the domain is all real numbers besides 2 and negative 2. Because if it is 2, right, 2 squared minus 4 is 0. And the same thing for negative 2. Negative 2 squared is 4 also. So 4 minus 4 is 0. So at 2 and negative 2, it's undefined, which means we have to exclude that from the domain. So all real numbers except 2 and negative 2. Okay. All right, let me jump to the definition for today. Okay, so the domain of a function is a set of real numbers that the independent variable is permitted to have. The domain of a function is a set of real numbers. So note that we don't include imaginary numbers, or in other words, complex numbers, right? Domain, we strictly talk about real numbers. Okay, real numbers, if you remember, it's everything, yeah, all the numbers basically that don't use I. Okay, so pi is a real number, e is a real number, 1/2 is a real number, all the integers, real number, 0 is a real number, right? Okay, so we're only talking about those numbers and not imaginary numbers, which would be like 3 plus 2i, right? Okay, so please pause the video here if you need to copy this down. And then from there, let me just review briefly set builder and interval notation. So for the do now, right, if you remember, it's everything besides 2 and negative 2, right? So for set builder, you have these curly braces here, right, looking fancy. And then you have x such that this vertical bar is a direct, like you can directly translate it to such that, right? So x such that x is not equal to negative 2 and x is not equal to 2. So everything else is fair game. Okay, so this is set builder notation. And here we have interval notation. So interval notation uses parentheses and brackets. Okay, so in this case, we just use parentheses because 2 and negative 2 are not included in the domain. right? If they were, then we would use brackets, right? Okay, but here they're excluded, so we use parentheses. So actually, let me draw a number line here. So we have, yeah, this is not going to look pretty, but so -2 and 2, right? Okay, so everything besides this, so I'm going to have an open circle here, right? If you remember, open circle means it's not included. Closed circle means it is included. So everything besides these two numbers is okay for the do now, right? So this is okay, and this is okay. Oh, sorry about that. Let me get that. And here we go. Okay. All right, that'll work. So -infinity to -2, not including -2. And then you also have -2 to 2, which is this part. And then union. Oh, we're going to use union here because we're like piecing them together. So union joins them, right? And then lastly, we have 2 to infinity. Okay. So that you can draw a number line. I find that to be very helpful when you're writing interval notation. Okay. But sepal notation actually is pretty easy because all you have to do is just write what you got for the answer, right? Everything besides -2 and 2, right? But for interval notation, it's a little more involved. We actually have to think about which values are okay when we're writing this. Okay. So here's your final answer for that. Okay. All right. Moving on to the worksheet. Let me sorry, I need to redo that. Sorry, I'm just gonna try to erase this. Yeah, okay, there we go. All right, so next is we're gonna go over this quick example, and then we'll get to the worksheet, okay? All right, so this example here is express the domain of the following function in both notations. By both notations, I mean set builder and interval notation, which we just saw. So this function is g of x equals square root of 9 minus x squared. So this is a classic domain question because the square root, right, the radicand, the thing that's under the square root. So radicand, that's just a fancy word for whatever's under the root. Doesn't have to be a square root. The radicand has to be greater than or equal to 0 for even roots. So you can imagine a 2 here, right? It's a square root. It has to be greater than or equal to 0. So it could be 0, right? It has to be greater than or equal to 0 for even roots. So like 2, 4, if you have a fourth root, sixth root, right? For cube roots, anything works, right? So like you could have a cube root of a negative number, and that's okay. Okay, but for even roots, just keep in mind that the radicand, whatever is under the radical, has to be greater than or equal to 0. Okay. All right. From there, let me jump to the solution. Feel free to pause here if you want to try it on your own, right? But from here, I'll go over the solution. Okay, here we go. So here it is. Oh, actually, let me type this in. All right, so we can't take the square root of a negative number, right? So we must have the radicand, 9 minus x squared, greater than or equal to 0, right? Square root of 0 is fine, right? Square root of 0 is 0. That's okay. Solving this inequality, we can add x squared to both sides. We'll have 9 greater than or equal to x squared. And then I solved this graphically, actually. In a later question, I'll show how to solve it algebraically, which is quite involved. We're going to use the same method as in algebra 2, right? We have to make a table of values and then like test out values. But here, for the sake of this question, I'm going to solve it graphically, which is much easier. I just solved this using Desmos. Desmos is an online graphing calculator. So I just graphed x squared, right? And then you have this line in blue, which is y equals 9. So this inequality is saying like, where is x squared less than or equal to 9? Okay, so it's less than or equal to 9 between the x values of -3 and 3. Okay, so anything that's in red here is below a value of 9, right? So anything between -3 and 3 is going to be our domain. Okay, Note that this does include -3 and 3. So this is -3 less than or equal to x less than or equal to 3. The reason for that being, right, this could be equal to 0. So at -3 and 3, this radicand will be 0, right? So 9 minus 3 squared is 0. Okay, that's okay, right? Okay, so therefore our final answer is going to be, in set builder notation, is going to be x such that x is between -3 and 3 inclusive on both sides. And then interval notation, this one's easy, thankfully. It's going to be -3, comma 3 in brackets because, again, those values are included. Okay. All right, from here, let me get to the worksheet. All right. So here's our first question. Find the domain of the following functions and express it in both set builder and interval notation. So this first one's easy, right? We have x is not equal to 3. Oh, before I move on, by the way, again, as always, if you want to try this problem on your own, well, you'll see the worksheet on Google Classroom, the classwork. And I had a couple people ask me yesterday, if you have to submit the classwork. You do not have to submit the classwork. You only have to submit the homework. Okay, so classwork is just for us to practice. Okay, so again, if you want to practice this on your own before seeing the solutions, please pause the video here and yeah, just don't reference the solutions here. Okay, all right. But yeah, if you are watching this right now, I assume that you want to go over the solutions. So here we go. 1 over x minus 3. The denominator can't be equal to 0, so we have x minus 3 is not equal to 0. So that'll just translate to x is not equal to 3. So anything besides 3 is okay. And then if you draw a number line, besides 3 is okay. Okay, so everything is okay. Okay, open circle here, and then everything else. All right, not the best picture, but I'm using my mouse, my laptop mouse to draw this, so not the most accurate. I apologize for that. But yeah, as you can see, it's -infinity to 3, union 3 to infinity. All right, next question. Here we have x plus 2 over x squared minus 1. So we only have to really care about the denominator here, right? So x squared minus 1 cannot be equal to 0. And then we would factor that. Okay, actually, let me show that here. Don't know why that's so big. Okay, so 1 0, and then you can factor, right? X minus 1, x plus 1, 0. So everything besides 1 and -1 is okay. Okay, so in set builder notation, x cannot be equal to plus or minus 1. That's your answer. For interval notation, it's a little more complicated, right? So here, right, just for the sake of time, I'm gonna not draw the numbers. So like, as you can see, like this will be -1, and this will be 1, right? Everything else besides those values are okay. Right? So -infinity to -1, -1 to -1. That would be this part, and then 1 to infinity. Okay, so that'll be your set builder notation. All right, next we have question 3. And that would be small. Okay, that would be x is, so x minus 5 can't be, or has to be greater than or equal to 0, right? That's the radicand, right? It has to be positive or 0, right? So this would become x is greater than or equal to 5, which gives us this answer here for set builder. And then for interval, it's just 5 to infinity. 5 is included because 5 is okay, right? 5 minus 5 is 0, square root of 0 is 0. That's okay. All right, question number 4. This is an odd root. So So here I'll just write the answer. Yeah, so this is actually all real numbers because, right, the cube root of a negative number is defined, right? Um, so yeah, like the cube root of -8, for example, would be -2, right? Because -2 times -2 times -2 is -8, right? So the cube root of a negative number is defined over the set of real numbers, right? So you can write t such that t is an element of all real numbers. Okay. By the way, that's what this symbol means. This epsilon symbol. Oh, that's right here. So this epsilon symbol, Greek letter. It's in math. It means is an element of. Okay. So that symbol is directly translated means is an element of, and then this r here is a set of all real numbers. Okay. For interval notation, you're going to write -infinity to infinity. Okay, so that'll be easy enough, right, for cube roots. All right, next we have another square root. Let me just copy this. All right, so 2x minus 5 greater than or equal to 0. 2x is greater than or equal to 5. Dividing both sides by 2, we get 5 over 2. There. All right. Okay, so x is greater than or equal to 5 over 2. That's set builder. Interval notation is 5 over 2 to infinity. 5 over 2 is included. All right, last two questions, then we'll be done. These are more difficult. Okay, so we have square root of 2 plus x in the numerator and then 3 minus x in the denominator. Okay, so for this, we have 2 plus x is greater than or equal to 0 for the numerator, right? Because remember, anything inside a square root has to be greater than or equal to 0 in order for it to be defined. So we have x. If you subtract 2 on both sides, you get x is greater than or equal to -2. And then 3 minus x is not equal to 0, so x is not equal to 3. Okay, and then it says, I write here that if you draw a number line, you'll see that these two sets intersect. So whenever you have like two different sets, as we do here, like x not equal to 3 and x not greater than or equal to -2, if you're solving a domain question, it has to be the values where they intersect, because it has to be okay for both, right? As you'll see, I'll give you a more concrete example in a sec, but yeah, so this is -2, and then 3. All right, so for greater than or equal to -2, this is included, right? So it'll be closed circle. Anything greater than or equal to -2, so we're gonna go to the right here. Okay, that's okay. All right, and then for this, x cannot be equal to 3, so I'm gonna draw an open circle here. So where they intersect is gonna be our answer, okay? So that'll be this part here. Okay, so basically anything greater than 3. Okay. Oh, sorry. I forgot to shade this part. So for not equal to 3, right, that includes this side as well. Right? But after that, -2 doesn't get like quote unquote covered there. So we're not going to have answers in that part. Like, for example, let's say you plug in -5, right? -5 would not be okay because 2, if you plug in the numerator here, 2 plus -5, that's a negative number, right? Square root of a negative number is not okay. But if you plug in a number here like 0, right? 0 is between -2 and 3. That's okay. So you have 2 plus 0, so square root of 2 in the numerator, and then denominator is 3 minus 0, which is 3. That's okay. Yeah, so you'll see that these two sets intersect from -2 to 3, which is this part here, and then 3 onward. Okay, non-inclusive of 3. And so this will be our final answer for set builder. and interval notation is -2 to 3, inclusive of -2, union 3 to infinity. Okay, note that 3 is not included, right? So open circle can't be 3. All right, so that's your final answer for that. All right, last but not least, we have question 7. So this is parts. Okay, so this is another example of an even root. So just the fact that it's a 4 doesn't really matter. It's just kind of like another thing to know, right? It's just testing your knowledge of even roots, right? So for even roots, again, as I said earlier, radicand has to be positive or equal to 0, right? So the input to an even root must be non-negative, right? So positive or equal to 0. We have x squared minus 6x greater than or equal to 0. Or if you factor that, x times x minus 6 greater than or equal to 0. You're going to have a similar question to this on the homework, by the way. So please pay attention to this especially. We're going to make a table. So this might seem familiar to you if you remember this from Algebra 2. We're going to find the zeros because that'll tell us like where the graph like goes from negative to positive. So just find the zeros first. So the zeros for this expression will be 0, right? Because you plug in 0, you get 0. And then 6, right? So you plug in 6 here, you get 6 times 0, which is 0, right? As I write here. Okay, so yeah, that'll be what divides your number line. And then you have to make a table of values for whether it's positive or negative for each of the factors. Okay, by factor, I mean like all the things that are being multiplied. So x, so sine of x, that's what I mean there. And then sine of x minus 6, that's this factor here. And then last, we have sine of x times x minus 6. So we just have to make sure that this thing is greater than or equal to 0. Okay, so you just plug in values, right? So in this, let me draw the number line. I think that'll be helpful. So let's say we have 0 here. I'll draw this on the top. 0 and 6. Okay, so negative infinity to 0, that's this part here. Just plug in any number. Let's say it's -5, right? So is the sign of -5 negative or positive? No brainer, right? It's negative. Okay, so you put that negative there. And then sine of x minus 6 at -5. So -5 minus 6 is -11. So that'd be negative, right? And then if you multiply that, right, x times x minus 6, right, a negative times a negative is a positive. Okay, so that is actually okay. So I'm going to shade that in here. And then I'm actually going to draw a closed circle here because at 0, at x equals 0, this is defined, right? Because it'll be 0 minus 0, square fourth root of 0 is 0. Okay, so that's okay. So I have a closed circle there. Moving on to the next part of the number line, 0 to 6. So let's say you plugged in 3, right? Sine of 3, that's positive. Positive 3 is 3. Sorry, positive 3 is positive. And then we have 3 minus 6. 3 minus 6 is negative, so you have negative there. And then positive times negative, that's negative, right? So this is negative, so that would not be included here. So I'm not going to shade that in. 6 is included, so I'm going to draw a closed circle there. And then for the last part of our number line, 6 onward to infinity. Let's say you plug in the number 10, positive 10 is positive, then 10 minus 6 is still positive, right? And then 10 times 10 minus 6, well, that would be positive times positive, right? So that would be positive. Okay, so this is okay. So therefore, our final answer would be negative infinity to 0, inclusive of 0. Then we're going to skip this middle part, and then we're going to go to 6 to infinity. Okay, so that'll be your final answer for interval notation. Yeah, brackets here, right? Remember, because it's included. Yeah, well, I actually write that there. 0 and 6 are included because when x equals 0 or 6, the radicand is 0, right? This will be 0. And the square root of 0 is 0, which is okay. And set builder notation, that would be x is less than or equal to 0. This one you actually have to kind of think about because yeah, we had this table here rather than like an algebraic expression, in which case we would just translate that directly to set builder. But here, just note that it's x less than or equal to 0. That's this part here. And x is greater than or equal to 6. Okay, so that is your answer here for set builder. And this is your answer for interval. All right. So if you're still with me, good job today. And just remember to have these notes um, already, looked over. So I assume that by the time you enter the synchronous Zoom session, that you would have already watched this video and understood, or at least try to understand these concepts and questions. Okay. But yeah, that's it for today. From there, just a reminder to complete your homework, which is right here. Okay, so complete that homework for tomorrow night. Okay, other than that, I'll catch you guys next time.